All right. How's it going, guys? All right. As always, the chat's on my window. Let me know if there's any issues. This is the last lesson before we start into our next foray of adventures with Java. We're going to finish up general classes right now with the constructors. I'm going to go over a little bit more on what the constructors do, how to use them, how to configure them, make your own custom versions of those so that you can get more power. And this is going to eventually lead into some really slick design, some design that you can actually put together when you architect code that's more flexible for the future. And we'll talk about that later, but just keep in mind that constructors are not just for creating an object. They are used for providing better design later down the road. So, also, this episode may contain alcohol use because I'm going to be celebrating with one of these Coronas right here. Oh, Corona. So I'm going to be having some beer because this is the last class. This is class number 11. We've made it a long way. So for those of you that are following along and have made it this far, congratulations. You are one of the few. And I am very excited to take you guys further down this rabbit hole and to teach you a lot more interesting things as we go. So without further ado, let's get started. Cool. All right. So, first thing I want to talk about is constructors. What is a constructor? Okay, well, I probably should have done this ahead of time, but I'm going to do it right here. All right. So, constructors. All right, cool. Yeah, adjust my mic really quick. Make sure everything's set up. All right, perfect. All right, so what is a constructor? Right, okay, so when you create an object, all right, generally what you've got is a class. Okay, so you've got class, my object, and we're going to say it's got this body, right? And you're going to have like, I don't know, like a string, my string, right? And this is private, right? Because it's a variable. All right? So let's pretend that we've only got this. Now, classically, what you've seen is this is public, and you can literally call my string directly. But we don't really want to do that. Okay? That's not at all how we want to run things. We want to hide the actual information, because what if this variable was a complex object? What if it was a complex data structure? And we didn't want the user of this code to be able to access the underlying data type and modify it directly. What if we wanted to provide, I don't know, get the sixth person in line? You know, we wouldn't want to expose the whole line. We want to expose only the sixth person so that they could act on that data rather than figuring out who all the rest of the data is. That's not how you want to write the code. So essentially what we're going to do here, okay, we're going to talk about a bunch of different concepts here, but first is constructors. There is a concept of a constructor, and this is a special function that exists only on creation time. Okay, so the way this works is we basically have public, the name of the class, open parentheses. Okay, now what I'm showing you right now is a method. Okay. When you create your class, you do not have to specify the default constructor that takes in no parameters. You get it for free. If you don't specify it, it's used behind the scenes and it's called magically. You don't know about it, right? And so what happens in the constructor? A bunch of things that have to do with Java itself, but nothing to do with my string. So absolutely nothing happens to your class per se. There's a lot of like interesting things that happen behind the scenes, but nothing on the data that you specify here. So from your perspective, nothing changes when you do not specify this constructor. Similarly, if I were to create this right now like this constructor also would not cause any any visible differences. Okay. Now, where this is actually kind of cool is you may have seen where we actually can initialize a string to the empty string like this, right? But you could also do it like this. Okay? So you can have any arbitrary value, right? Set it that way. Okay, so that is a constructor, all right? And I'm going to run through a couple examples. Hold on 1 second. I lost my place. 1 second. Okay, cool. All right, so I'm going to talk about this particular example where it's literally just the default constructor. So what we're going to say here is default constructor. This is created automatically and called automatically, but here we have specified it explicitly. Okay, I'll fix my terrible spelling or typing or whatever that is. Cool. All right. So let's go over to our constructor demo. All right. Now I'm going to create a class in here. Okay. And I'm going to call it my class. Okay. This class has a single integer. And I am going to, I'm going to start doing this and start making this public. I'm pretty sure that's fine. Should be. And then I'm going to say that the constructor here is just the same, overloaded empty constructor. But just like I showed you in the example on the blackboard, I'm going to say that I want to default the value to 10. Okay. And then in our previous example, I showed you how to make a method that returns a value and takes in some values, right? So what is the way you do that? Well, remember, it's return value, method name, parameter type. Hold on, let me fix that. Parameter type followed by parameter value. Okay. Let's return value. And then I want to return the return value. Okay. So let's fill in the blanks, right? So the method name, I'm going to say get x. And this getter does not take any information in, so I can remove the parameter. And I can say that it's going to return an integer. Okay. And then I can say, well, I want to make it public as well, by the way. And then I'm going to say it's going to return x. You could also say this.x if you want, remember. But for the sake of cleanliness, we're going to do that. Okay, cool. So now in main, I'm going to create an instance of my class. And remember, a lot of this is basically review, except for this magic sauce right here. So everything we're doing right now, creating this class, creating a getX method, is all what we did last class. Now we're adding the constructor where we can default the value. So instead of defaulting the value in main, if you remember last class, we'll go over here and we will show we basically made a vehicle and then we set all the values in main, right? We're going to remove this complexity. We're going to hide it in the constructor, which is this guy. Okay? Cool. So I'm going to literally say my class T1 equals new my class. And then my class T2 equals new my class. All right. I'm going to do system.out. Print line, and we're going to say T1.getX. And then we're going to separate by a space. and we're going to print out t2.getX. Now, what I want to show you, I think this is fine. Make this explicitly private. Can I access it? Not. I shouldn't be able to do this. I'm going to see if that compiles. It may compile because this is a class inside of this class. Let's find out. But generally, you want to hide these in functions, and I will be showing you how to put classes in their own files very shortly. And when we do that, you cannot call the private member directly. So let's actually find out if this works. So let's go over to class 11. Oh, this is the constructor demo. So let's go ahead and try that. Copy reference from static content, not static. Oh, it's because I specified it that way. I believe that's why. Nope. I have to make it static. Kind of dumb. Okay, so as you can see, both are 10. I have to make it static because it's within this class. And apparently this matters not because it's part of constructor demos. So apparently constructor demo can access everything of this class, which I don't like. So I'm just going to change that to get X because that's better code. You don't have to go back and change it later. Okay? So essentially you're looking at 10 space 10. So now notice how clean this looks. Looks pretty good, right? But now I'm thinking to myself, well, what happens if I don't want it to be 10? That sucks, right? That's not very extensible, right? So imagine you're building some complex system and you're creating an object. You built this crazy complex object and you want to be able to put your own specific data. You want to configure it to your own values. Well, welcome to Parameterized Constructors. Okay? What I'm going to do here, I'm going to copy this class. All right? And I'm going to go over here. Do the same thing. Okay? Now, here is something magical. I'm giving you two concepts at once here. 1 second, I am bleeding power right now. I don't know why. It's like my computer is not. Please bear with me. All right. Okay, is everything still good? All right, looks like we are back. Sorry about that. Apparently my charging cable was not plugged in the whole way and I'm down to 23%. So, okay, so I'm gonna throw two concepts at once at you. The first is, I'm gonna tell you that you're allowed to have multiple constructors. And you're like, whoa, whoa. And there can be the same name. And you're like, whoa, that's crazy. How can you have multiple methods the same name? Because your first thought is probably like, how does it know what one to use? And you can have multiple constructors if the function prototype, which is the types and the order of the values that are passed into the constructor, are different than an existing one on that same class. So I cannot do this. I can't do that. But I can do this. That's allowed. So what we're going to do is we're going to take advantage of this, okay? And we're going to add another constructor. And we're going to say that I can now create a class by passing in the value that I want it to be. And I set this.x. In fact, this is an interesting thing I see a lot. So there's two x's, the one in the class and the one here. It will always assume that the one being passed in is the one without the this, keyword, and the one with this is the one that is the variable that you've declared. Okay, so check it out. I mean, what I've done is I've said, okay, I want to be able to create one with default, but I also want to be able to specify my own x value. Okay, getX will always return the same x no matter what, because it's always acting on x. But in this particular case, I'm able to pass in the value rather than explicitly relying on the class to do it internally, because what if I want it to change, right? So let's go ahead and let's go back to the constructor demo here. I'll grab this code. Okay. And we're going to change it slightly. I'm going to leave the first one the same, and I'm going to change this one to say 89. Okay. Notice this, IntelliJ told me that that's the parameter value for x. Pretty nice. It's a pretty nice little thing. So I should expect T1 to print 10, okay, and T2 to print 89, because I've specified in this constructor that gets passed through and set that way. So this is calling a different constructor than this one. And there's your flexibility. You can have as many constructors as you want. It's always bad to have too many constructors, but you build what you need, right? So let's go over here, clear the screen. 10 and 89. It's pretty sweet, huh? So now we're getting a little bit closer towards being able to build a robust system where you're able to basically specify data outside of the objects that are going to be reused across multiple different systems. Okay, cool. So now I want to grab we're going to do the vehicle constructor demo, but I want to go over here. I want to grab a vehicle. So what was yeah, this is the cool one. So, all right. Looks like I put it outside the other class before. Okay, so, all right. In this particular instance, before we have to actually modify these values externally, right? And I don't want to do that. I don't want to do that at all. So what I want to do is I want to create a constructor. So what's the rules of the constructor? Well, first, is it public or private? In this case, I'm going to make it public. And I'm going to say it's a vehicle. And I'm going to say, okay, let's start with the default constructor. But what do I want this constructor to do? Well, I want it to take in the passengers. I want it to take in an integer for the fuel capacity and an integer to take in the miles per gallon. And then what do? I say this object's instance of passengers is equal to the passengers passed in. This object's instance of the fuel capacity is equal to the fuel capacity passed in. And this object's instance is the miles per gallon equal to the miles per gallon passed in. Monkey see, monkey do. It's the same thing you did in the last one, except now there's two more parameters. Same exact thing. Okay, so let's write this out because it's been a week. So we're going to say we're going to construct complete vehicles here. Okay, and we're going to say here's our vehicle. We've got a minivan. And classically we say new vehicle. And be like, all right, sweet, minivan this, minivan that, blah, blah, blah. And no, we don't have to do that because we're literally going to say, well, I want my passengers to be 7. I want my fuel capacity to be 16 miles per gallon, 21. Done. Check it out. Simple as that. One line instead of an extra 3 per vehicle, right? It's pretty nice. Now we're starting to see where not just the design of the code can lead to better and more flexible options, but also cleaner code, right? So we're going to do 2, 14, and 12 here. And then remember we were doing the gallons check out. Let's actually just grab that from the last one. So I think we just grabbed all this. Or we can grab all this because I'm pretty sure this is all going to be the same. Because we still have method fuel needed, right? We still have the method range, which I don't think we're using here. Anyway, that should function just the same. So let's just kind of run that. Oh, whoops. Yeah, it's because we needed a couple extra things. If you remember, we had these variables here. So we're going to pull those into this example. Right, because we hard-coded the distance here, we calculated the gallons using the fuel needed function, passing in the distance for each one of these sports cars, or sorry, the minivan and sports car, and then we printed the distance and then the gallons. Okay, and so by running that, cannot find symbol. Oh, it's because I spelled vehicle wrong. Problem. Okay, let's clear that. Try again. And there we go. Same thing we got before, except look what we did. Look at class 10. In class 10, we had this whole bunch of code here, all right? And notice how we don't pass anything into these constructors up here, right? Now we've reduced that code, and now we've created these constructors here. It's pretty awesome, huh? All right. This may be a very, very quick lecture because most of these principles are, you're probably already kind of seeing a lot of these things before. So constructors, called when an object is created, and you can then also parameterize them just like you would for the methods, like this fuel needed method, right? Pretty cool, huh? Okay, so new. We go to the blackboard because this is more conceptual. So this is not something that you need to be ready to do something with. I hate methods. All right. So I just want to talk briefly about the new keyword. And this is going to be short, but so basically you're going to have a class variable, and you're going to say equals new class name, right? And then argument list, or in other words, parameters. And that's the template for creating an object. You've got your variable of the particular type, you call new, and then that class name, and then you pass in the relevant information. Okay? And this is basically allocating memory in the system for your object to be created. Something to keep in mind, and this leads into the next section, is that this is creating a reference to a newly created object that's been allocated in memory. So when you do this, you are basically saying to your computer, I want you to allocate a part of my RAM stick to hold this size of data that maps to this object. Because this class type, whatever it is, it's a specific size. And you probably remember that from when we talked about like different data types back in like lesson 1 or 2. I think it was 2 or 3 actually. I said that the size of all these pieces, whether it's an int, a double, a float, a string, whatever, these all add up to be the size of the object. In this particular case, when you call new, you're allocating memory in RAM. Okay? If you overflow the RAM, okay, this is important. If you allocate more money than you have enough RAM for your computer, usually fine because you've got what's called virtual RAM, and you start to use, I don't really know a whole lot about that. I'd have to look into it, so I could be wrong when I say this, but pretty sure it allocates it on hard disk, and it creates an actual block of memory on the hard drive, so it's super slow because it has to actually access the hard drive. And so if your application has to get into virtual RAM, it means that you have a lot of other programs running that are preventing your program from running or being able to have access to enough RAM to be running optimally. So it's not necessarily your program's fault. It could be some other program on your device that's causing the issue in the first place. So essentially what new does is it allocates a block of memory. So I'm going to write that here. Okay? Conceptual. Nothing to do with programming. Something to keep in mind and remember. Okay? Memory is finite. Okay? If your application cannot allocate memory, you will get a runtime exception. Something that looks kind of like this. Probably it's an explicit exception that maps to memory you're out of memory, but you've run out of memory, and you will find that out because your program will crash, and it will tell you that that's why it crashed, and then you got to figure out why it crashed, and that's going to be hell. So keep that in mind when you're writing your applications. Okay. All right. Garbage collection. Okay, so in C++, this doesn't exist, which is why C++ is a lot harder and why a lot of people say start in C++. I would advocate for that, but if you are coming to Java as a fresh new programmer, that's all fine, because I'm not teaching you C++, but I will teach you the differences. In C++, you are expected to not just allocate your memory, but also delete your memory and give it back to the computer. If you do not give your memory back to the computer, then you can end up having a memory leak. And memory leaks mean that all that information that you allocated in your RAM sticks around for a long time. If your application runs for days and it's constantly allocating memory but never giving it back to the RAM, eventually your computer is just going to crash. It's going to be like, I don't have any more memory. It's going to think that all that memory is still in use, when in actuality you done screwed up, right? You just made a mistake, and that's all problematic. It's garbage, but that's exactly what a garbage collection system does. It's kind of like a Roomba. Your garbage collector is like a Roomba that goes through, and it's part of the Java virtual machine. So Java is basically an extension of a native language. So C++ is called a native language, and you have to do everything on your own. But Java is a managed language, and what that means is that it has a virtual machine that it's built on, that runs the Java code. And so part of what Java does for you is it runs something called a garbage collector. So every so often, the garbage collector will run, and it will go around and it will say, okay, is there anything that isn't being used anymore by anything in the system that's just hanging out for no reason? Oh, cool, I found something. Let's give it back to RAM, and then, ta-da, it's done. You don't have to worry about it. And that's really, really cool. But there's also some gotchas with that. A big gotcha with the garbage collection system is that it runs on a schedule. It doesn't just run once a frame, which would be every time the computer updates. Like, it doesn't do that. It'll run, it'll wait some amount of milliseconds or something, I don't know what the number is, and then it'll run again. And so effectively, if you rely on the garbage collection system to do the work for you, meaning you just don't care about how your objects are connected and just let everything fly to the wind, what happens is that every time the garbage collector runs, imagine a Roomba that you just threw crap on the floor. You just threw a bunch of shit on the floor, and your Roomba every once in a while ran once an hour, and it just picked up everything. Okay, well, that's awesome, but your Roomba's going to get stuffed full of garbage really fast, and you're going to have to go clean it. And that's exactly what happens when the garbage collector runs and you're not writing clean code. The garbage collector is going to get full. It's going to have to do a lot of work, and so when it runs, you're going to see your memory performance go for like a split second and fall down. You're like, okay, well, it's only for that little split second. but your program is going to look like it's lagging to the user for that split second. So it gives the end user that's using your application the perception that there's latency, lag. Like if you're playing Counter-Strike and you shoot somebody and then all of a sudden you're dead and you're like, what happened? It's because, well, they shot you first, you just didn't see it because your internet connection sucks. But same with this. The Roomba runs and it gets so clogged with garbage, it's got to take time to clean itself out. Same with the garbage collector. So the idea here is that you want to write clean code. So what is a garbage collector? Runs every so often to find allocated objects or memory. Well, we'll just say allocated memory, and we'll say AKA objects, etc., that aren't being used anymore. Warning, if there's a lot of memory not being used when the collector runs, okay, you may experience a slight moment of latency in your application. Okay? That sucks. Nobody wants that. Okay? So, the garbage collector is a safety net for people that are hobby programmers that aren't writing massive applications. As you start out, you're going to be doing that. You're not going to really notice this a lot. When you start writing enterprise, large-scale applications that do a lot of different things, you're going to see this, and you're going to wonder why your program is starting to have these really weird blips once in a while, and the answer is that your garbage collector is working a lot. So, you want to keep that in mind. So that brings us into a special object that you can add to your system that will allow you to handle certain things. And a lot of people will tell you maybe that this is not the best way to handle things. I'm going to advocate that use it with great responsibility. Okay? You can find yourself in some weird situations if you use this, but use it correctly, right? And you want to do some research on this to figure out the best ways to use it. But essentially, Java objects, anytime you make a class called myClass, okay, it actually, even though you don't see what happens here, it actually extends object. What does that mean? We'll get into what this means later, because extends is a special notation that means inheritance. It means that my class is an object. Again, don't worry about it. But what it essentially means is that my class is picking up a lot of this stuff for free. And one of those methods is a secret, not so secret method called, and you know what we'll do? We'll do this so you can see everything in play. We'll do this so it makes more sense. We're going to say object, and then we're going to put a comment here that says this is a Java-specific class that all classes you create get for free. Okay? Now, in this class, there's a method, and it's protected. And if you remember from one of our earlier lectures, there's private, protected, and public. Protected means that objects that subclass this, meaning if you make a class, it automatically gets the object stuff for free. One of the methods it gets for free is anything that's protected. Okay? And so what happens is you have a method in here called Finalize. And this is something that if you're just starting out, you're not going to know unless somebody tells you about this kind of stuff. If you go to the Java website, and actually, why don't we do that? We can do that here. Let's go to Java Object. Okay, that's not working. Let's go here. Come on. Okay, So we have Java object. Okay, so this is, so it says class object is the root of the class hierarchy. Every class has object as a superclass. Again, we'll get into superclasses and all that. But anytime you make an object, a class, it's going to have object as something that it gets for free. Okay, it won't explicitly tell you, but you get all this stuff for free. You get clone equals finalize get class hashcode notify all toString wait. It's pretty cool stuff. So the one we're talking about right now is this one called finalize, and this method says called by the garbage collector on an object when garbage collector determines that there are no more references to the object. Okay. A subclass, in other words, the class that we're about to make, or that I'm going to show you, it overrides the finalize method to dispose of system resources or to perform other cleanup. Okay, so I'll let you read this. If you go Google this and read up on it, this is sort of like your exercise, your homework. I think you should read up on this. It also throws an exception. So remember, we've done stuff with exceptions where you kind of have to say if you use this code, you have to make sure you deal with this. I'll leave this as an exercise to experiment with and, Google how to do this. At this point, you should be getting used to using Google to figure some of this stuff out, but using finalize is kind of cool. So if you actually overload this, and I'll write this in the Blackboard code, I encourage you to go and make an object with this method, and then, just go ahead and set the thing to null. Maybe write a loop that loops like 20 million times, something. Doesn't print anything, it just loops 20 million times, and then wait for your print statement in here to be printed, and see when it prints. Maybe, check it out that way. But you should be able to see a log statement, like a print statement, be printed to the screen and see that this was called. But in any case, what happens is you get this for free. Okay, and so the way that you do this, right? And again, some of this stuff is advanced, but there's a keyword that you should use. Should use it. Called override. And then you make it public so that, I guess you don't have to make it public. You could make it protected. And you say void finalize, right? And then you can put your code here. Right? So that's how you say, hey, I know I got a function that I get for free, but I'm going to do my own thing. You can also do this. You can do that too if you want. You don't have to. Okay? So we're getting into some crazy stuff here, but really I just want you to understand that finalize exists and that it allows you to say, hey, I know the garbage collector is running. Here's some other stuff that I want you to get rid of because I don't want that to be taken care of later and cause another blip on the radar. I want to take care of it right here and right now. Okay? Okay, so that's finalize. I'm going to leave it up to you as an exercise to kind of go through and play around with that. If you look at the book that was listed with this course, you can find a lot of different examples that you can kind of code up and try. So we're not really going to go into this. This is more advanced things. This is not about programming in general. This is more about the Java language. This is something that Java gives you. And I'm not here to teach you Java specifically. You should learn on your own some of the concepts of Java. I'm teaching you how to program, okay? Cool. So now I want to take you to this keyword, all right? So I've already talked about this, all right? So what exactly does this do? Well, over here in our constructor demo, or actually this one over here, we call this. This actually just is automatically getting a reference of the instance of the class that you're currently talking about, okay? And that's it. I mean, I don't know what else to say. You basically get your allocated instance. So when you're inside of T1 and you call this, then you're talking about T1 because you're inside of this. I mean, it's pretty self-explanatory, okay? So I'm just going to kind of go over here and I'm going to do a little demo. So I'm going to do an example. Let's see here. Let me think about this for a second. Okay, we're going to write out a brand new program class, and then we're going to modify it. So we're going to start from what we know. I want to basically, I want to be able to take a number and I want to raise it to a particular power. Okay, so I'm going to have a constructor here. Make a public class too. So a public constructor. It's going to take in a double with a base, and then an int, which is the exponent. Okay. And I need to store those two things, so I'm going to say I got a double b, and I have an int e. It's terrible variable names, but I'm doing it anyway. B equals base, and I'll show you why I'm doing that momentarily. E equals exponent. Okay, and so I'm going to calculate the power in here, but I also need a place to store that value. So I'm going to store the value in V. Actually, I just looked up val. And so we start off with val equals 1, right? And the reason for that is because if the exponent that's passed in is 0, anything raised to the power of 0 is 1. So it's a failure case. So if our exponent is 0, right, we're just going to return. We're going to return. Now, we're not able to return a value from the constructor. So how do we get the value? Well, let's go ahead and make that getter. Get power, and we're going to return val. Right? This. Okay? So I've just kind of built out my functionality. Now let's figure out the case where it's not equal to 0. So we're going to loop. All right? And I'm not going to start at an initial value, so I'm going to keep that blank. And I'm going to say, while our exponent is greater than 0, okay, we're going to decrement the exponent. So we're going to loop for the amount of numbers that we have in the exponent. So if the exponent's 5, we're going to loop 5 times. And I'm basically going to say the value equals value times the base. Okay, and that's going to give us our exponent. Okay. So we just kind of built the power constructor that does all the logic for us, and then we can get the power later on after we created the object. All right, so that was a little fast, but I'm not here to teach you, again, not here to teach you algorithms. So I don't really, it's not up to me to teach you how to do an exponential, like a power exponent algorithm. It's for me to just code something up so you can understand, okay, here's a constructor. I want you to be able to understand that we're passing values in, we're doing some logic, and then we're storing the value, and then getting it from this method later out of the same object that we created called power. Okay, that's what I want you to take away from this. All right? It's not about what you can explicitly do in this method. Okay? So I'm going to create power x and say new power, I'm going to say 4.0 to 2. I'm going to do another one called y, and I'm going to set that up for 2.5 and 1. And then power z, new power, and then 5.70. Okay, cool. And so now all we got to do is print that out. All right, so we're going to do system out line. All right, x dot. I guess we can do this. Yeah, we'll do that fine. All right, so x dot e plus raised to the, so x dot e, and then power, because raised to the exponent power is, and then we're going to do x dot get power, okay? And then we're going to copy paste y, z, y, z, y, z. So let's run that, shall we? So 4 raised to the second power, 4 squared is 16. 2.5 raised to the 1 power is 2.5, correct? 5.7 raised to the 0 power is 1. Okay, so that's what we've done already, okay? So basically what I want to do is I want to convert this over to using this, which is just an example, but I really, really wanted you to understand the power of this and to get used to using it if you can. If I do this, it's the same thing because B is part of this. So anytime I see a B in here, look for B. It's the only place. Anytime I see B, actually this should be B, right? But I want to make that this. Cool. E. I'm going to change this to E. I'm going to change this to E. Change this to E because we don't want to use the values passed in. We want to store them and use them, right? But that means that now everything is this. So we're going to prepend E with this. Again, this is just for example purposes. Val is also part of the power class. So we can say this, this, and this. The only two things now that do not have a this are base and exponent, which are passed in. It's clear as day now. Oh, look, I forgot one. So return this dot val. Clear as day. Okay? And that's the point. It is cleaner to see this, so you know exactly what we're talking about, than having random versions of this thing passed around. I want explicit, in my face, denotation. Okay? So, let's run that again. Same thing. Oh, wait. Raised to the 0 power. Something didn't update power correctly. Let's look at that. So, power is the exponent. What's going on there? Oh, man. Looks like it worked fine. Ah. We are going to undo this. I'm going to show you where that bug came from. So you're noticing here how everything changed from 0 down all the way. And that's not good. This is why I don't like to do logic in a constructor. But essentially what's happening here is we've taken an exponent, we've set it equal to the value e, which is this. But then we've actually run through and we've decremented the actual value stored in the class. So by the time we get here to print it, it's not the right one, right? So we want to store the exponent so we can talk about it later, but we want to use the value, okay? We want to use this value because we want to operate on the one passed in, and we want to store the original value so we can report it in the print statement later, okay? So let's run that again. Okay, now it looks correct, okay? There's better ways to do this. I would honestly make a calculate function, right? I would make a public, in fact, what I would do is I would call this calculate, and I would do the logic in here. I mean, I wouldn't even store a value internally. It depends on what the purposes of the object is. This is an example, and by all standards, it's a pretty shitty example. Anyway, okay, cool. So that's the this object. So now you understand constructors, memory management, simple memory cleanup, and what the this object actually does. Geez, I don't even know where we go from here. Let's think about that for a second, because we are now done with chapter 4 of this book. So let's see, where are we going to do next? Let me kind of look here. So, oh, cool stuff. Okay, yeah. So here's the deal. We're going to take a week off because I need a week to kind of get ready for the next leg of this journey and start to kind of map out how I want to take this. So we'll come back probably next Thursday or maybe even the following Monday. I think I'm going to take 2 classes off. So probably come back not Monday, but the following Monday. Yeah, I think that makes sense. And we're gonna do arrays, okay? We're gonna deal with those. We're gonna do for each style loops, which is kind of cool way to use for loops without using for. It's like a really nice consolidated way. We're gonna start to do some string manipulations. We're gonna deal with command line arguments, like we're gonna figure out what exactly is this thing here, and why is it passed into main, okay? And we're going to do some bitwise operators, which is one of those things I talked about. You're able to actually change the bits instead of, like you have 8 bits to a byte, so like an integer was like 32 bits. Well, now you can flip individual bits. And that's really useful, but also it can be very confusing. So that's chapter 5. Chapter 6, we're going to be doing... we're going to talk about controlling access to a class's member variables and how to pass complex objects directly to another object. Okay, and that's where we get into the beginning stages of design principles. And that's really good stuff. Talking about overloading methods. More importantly, we're going to talk about static, inner classes, and recursion. Recursion is where a function calls itself, which sounds crazy because that sounds like that could end badly, and yes, it can. Can basically run forever if you're not careful. And then the crown of all things you're going to talk about is inheritance. You're going to talk about how I showed you in the blackboard that you can actually extend an object class. So like Java gives you this for free, but if you want to do it yourself, well, we're going to talk about that. We're going to talk about inheritance. How you create your own versions of a constructor and call back up to the creating parent, multiple objects that derive from each other, and you get this really crazy tree-like structure. And I'm actually going to start teaching you a little bit about UML design. And that's not where I'm going to take this course long-term, but that is actually the beginning stages of the second class I will take you through, which is called Design Patterns. So I'm going to give you a sneak peek at that, and that's probably a number of weeks away. That's probably about 3 months down the road. But basically, there's a book here called Design Patterns, okay? And it's written by the Gang of 4. This is a cross-language book, very, very, very famous, and it teaches you how to write elegant code and how to make everything connect together. It's basically like learning how to not just build the pieces of a house, but how to architect the house from the ground up, and that's a very important skill to have. Okay, so that's a lot more knowledge than you wanted or needed, but that's where we're taking this. We are going to get really complex. I'm going to teach you the fundamental building blocks of each of these pieces along the way. So take these classes and work on your own. Take the next week, take it off, or take the next week and putz around with some of the things that you've learned in a lot of these classes and get ready for that next leg of the journey, because we're about to do some really, really cool stuff that's it's going to allow you to start doing some really unique things on your own if you want to take this to the next level. So anyway, thanks for joining, and I will see you in about a week and a half. All right, see you later.